Alright guys, here we go. Welcome back. This is week 5. This is where we're going to start going into, again, some more of these new ideas. Where now we're working with statistics. The first thing I want to say is sorry about the last week. I had some issues with the recording. Hopefully this week I can figure it out. I'm really trying as best as I can. But what we started with last week was looking at mean, median, mode, and the range to help us look at information in a specific way, and now we're going to be looking at something called standard deviations. Now, we're just going to do an introduction to standard deviations today, kind of talk about what they are, how we use them, and then as we go through the week for the next 2 lessons, we'll actually look at finding them. But let's go over here and define what a standard deviation is. Standard deviation, there's a couple different ways to think about it. The first way is it tells us how spread out our data is, right? What that means is, right, if we have more spread out data, right, a bunch of numbers, let's say they range from like 1, 3, 6, and then like 19, 30, it's going to have a bigger standard deviation, where if we had numbers that were really close together, like this, where they're all very, very similar, that's going to have a smaller standard deviation. So the bigger the spread out, or the more spread out, the bigger the standard deviation. The less spread out, the smaller the standard deviation. The actual way that we use standard deviation, what we're actually going to call it, is it's the average distance, let's say, away from the mean. Right, now we know what the mean is. The mean is the average when you add up all your numbers and divide by however many numbers there are. What the standard deviation tells is how far each individual piece of data is away from the mean on average, right? So that's why the more spread out it is, the farther away everything is from the mean or the middle, where the more closely related all your numbers are, the closer it is to your mean or your average. Now, the last thing I want to do is I want to show you the symbol that we're going to use to represent standard deviations. So I'm going to say standard deviation. We're going to represent it with this symbol that looks like that. It's called sigma. It's lowercase Greek alphabet, but that's the symbol that we're going to use there to represent our standard deviation. The second thing that I'm going to add in here, because eventually, since we're looking at the average distance away from the mean, is our symbol that we're going to use for mean, right? So I'm going to come over here and say mean, right? Or I'm going to say or average. Like, we know how to find an average. We also have a symbol that we're going to use to represent that. So to represent the mean or the average, so I don't have to go out and write out mean and average every single time, is this. It's another Greek letter. It's called mu. Notice how it kind of looks like an M for mu or for mean. So that's what we're going to use to mu, that's how you spell it. That's what we're going to use to represent mean or average as we go through in these next couple sets of lessons. Again, standard deviation can be used to really tell us a whole lot about our numbers rather than just looking at the mean, right? Standard deviation takes it another level. It allows us to see a lot more rather than just like some of the stats that they give you, like, oh, the average amount of hours an average American teenager gets is like 6 hours, right? That just tells you a part of the story. Standard deviation kind of goes a little bit further than that. So what I want to do is I want to look at these two data sets over here. This is all we're doing, is we're just going to look at this. Now, eventually we're going to go through and we're going to be able to find the standard deviation, but notice over here, I have in orange the standard deviation. So let me, again, this is sigma, and I'm going to point at it and say standard deviation. For both of these, we have the standard deviation. Now, why I'm saying the mean or the average only tells us part of the story is because if we look at this, we have two different sets of data. And I'm going to say these are two different companies. These are the starting salaries that you get there. Why this matters is because when you're going into some sort of job or profession, you kind of want to know where you're going to start out. A lot of people do. So, what this employer or this company can do is they can just tell you, oh, the average starting salary that you'll get here is however many dollars. So, what I'm saying is there could be three people that make $20,000. There can be three people that make $80,000 starting. We can average that out again to find the average, and I'm going to use this symbol over here, mu, the average. We add up all of those numbers, divide by however many there are. I made this a little bit easy for us so we can just get the concept, but 20 and 80 makes 100,000, so we have $300,000 divided by 6 different salaries. I made it so this will work out to be the same thing. Our average salary there is $50,000. Now, I did the same thing on this data set below. Notice how we have starting salaries of 40,000, 45,000, 55,000, 60,000. The average, again, if we do the same thing, we add them all up, divide by 6, it's again going to work out to be $50,000. Now, why does that matter, you may ask? Right now, we're looking at this first company. Yeah, it does have a starting salary of $50,000, but if you dig a little bit deeper, the standard deviation is about $30,000, which means on average, people are about $30,000 away from that average, and that could be above the average or below the average, where these 20,000s are 30,000 below the average starting salary, and these 80,000s are 30,000 above it, right? So that's kind of interesting, right? We look down here at the second data set, and now we have the same starting salary, right? They both have a starting salary, an average of $50,000, right? But in this case, if we went a little bit deeper and we found the standard deviation, or the average distance away from the mean, or how spread out your data is, it's $8,000. Right now, all of these people are about $8,000, $9,000 away from that starting average, right? That starting salary that they're saying. So the question is, what would be the better situation to go into, right? If you were looking at this first company, right? You're either starting at 20,000 or you're starting at 80,000. Now, probably 80,000 if you have some certain qualifications, 20,000 if you're just like starting, right? Notice how if you start there, it's kind of deceiving to say, oh, our starting average salary is $50,000, because you're either starting at 80 or you're starting at $20,000. That's why the standard deviation is so important. It shows you that if you look actually deeper at the data, then you know that shoot, you could be making a lot at the beginning, or you could just be making pennies compared to some other people starting there. Where if you look at that second data set, we have a bunch of starting salaries that are very closely related. They're going from 40 to 60, meaning our standard deviation was a lot smaller, 30,000 compared to 8,000, right? All of those starting salaries are a lot closer together. So it's a little more, it shows that the average data is more true to what it's representing, right? All of those are a lot closer to 50,000 rather than the data set at the top. So what the standard deviation is kind of telling you is that that second company is a little more reliable with the information they're giving you with the average. Another big thing here is when you're looking at statistics, make sure you look at the big picture, because looking at just one individual thing like the average amount of this doesn't give you a lot of information, right? Always make sure you look a little bit further and don't just believe the first thing that you see there. I know this is just kind of like a vocabulary lesson, but I really want you guys to understand what standard deviations are. Again, as we go through here, focus on, we're going to write standard deviations as the sigma and the mean, or the average, which you guys have been finding. We're going to start representing it with that Greek letter of mu right there. If you have questions, please let me know. Have a good day.